This lab is BGP Multihop. So what I'm going to do in this lab is show you how to configure multi-hop configuration. The default for BGP, as mentioned, is that they expect neighbors to be directly connected. It's a path vector protocol, so there has to be a workaround if you're going to peer through a transit router. In this lab topology, I've got three routers. R1 is in AS 65000, R3 is in 65001, so there's external BGP pairing. And I've also got this transit router R2. On R2, I've configured static routes for forwarding between R1 and R3. There's also two LAN segments, 172.16.1/24, that's LAN 1, and also 172.16.20/24, that's LAN 2, connected to R3. So I want to configure BGP pairing between R1 and R3. I'm going to use eBGP Multihop to do that. I'm going to enable source pairing between the loopback interfaces of R1 and R3. So I'm going to do the pairing between the loopbacks and not physical interfaces of R1 and R3. Then I'll advertise the connected LAN and WAN subnets between R1 and R3, and also verify the neighbor adjacency, and also that eBGP Multihop is working correctly, and the routing tables. We'll start with R1 here. I've got loopback 0. This is 192.168.2551. That's /32. Then I've got this link to R2 transit router from gig00, and that's 192.168.1 subnet /30. That's this one here, R1 to R2. And I've also got this LAN segment on gig01, and that's 172.16.1. See that right here, /24. And the global configurations, router BGP 65000, and I've got a network statement for the LAN, 172.16.1, and that's /24 mask. BGP doesn't use wildcard masks, they use standard masks. And network 192.168.10, and there's the mask /30, that's the WAN segment. And I've got my pairing statements, 192.168.2553, and that's to remote AS 65001. And also neighbor 192.168.2553, eBGP Multihop 2. And finally 192.168.2553, update source loopback 0. So this 2 means 2 hops, maximum 2 hops. The default behavior of eBGP is to have a TTL of 1 as it leaves this physical interface gig00. So what happens is if I didn't have that eBGP multihop, it would get to R2 and that would be TTL 0 because it'll decrement it and it would be dropped. But if I have 2, that'll leave at TTL 2 at gig00. It'll get to R2, decrement it to 1, then forward it on to R3 and then decrement it to 0. So that's why you need the 2. The other thing to note is I don't have any disable connected check, although I'm pairing off this loopback address. And the reason is whenever you enable this multi-hop command with a value of 2 or greater, the disable connected check is automatically configured. So it's done automatically, I don't have to do it. And since it's pairing with loopbacks, I have to put in a static route for the neighbor loopback address. That's 192.168.2553 and /32 mask, and 192.168.12, the physical interface. That would be the interface on R2, 192.168.1.2. So that's the next hop forwarding address. I'll go to R3 and do the same thing. It's got a loopback. It's got a loopback 192.168.2553. It's also got this gig00 interface. This is the link to R2 transit router, and it's on a 192.168.2 subnet. So there it is there. So that's the link from R3 to R2. And also the LAN segment 172.16.2. That's this here, directly connected. And the global commands are router BGP 65001. Got network 172.16.20. That's the LAN subnet, and it's using a /24 subnet mask. And also network 192.168.20. That's the WAN subnet between R3 and R2. And the neighbor command 192.168.255.1, remote AS 65000. That's the peering statement. And the eBGP Multihop 2, that's the statement I need to modify the TTL value. Then there's neighbor 192.168.2551 updates source loopback. And also the static route to the neighbor loopback address via the next hop 192.168.21, and that would be on R2 there, the gig 01 interface. So it sends it to R2. R2 has a static route, just forwards it on to R1, and the TCP peering works fine. Next thing I want to do is verify neighbor adjacency and verify eBGP multi-hop is working, and also routing tables. So we'll just go to R1 here. Just do the summary command. So first things, I'm going to verify the peering. So 192.168.2553, that's the loopback on R3. And 65,001 is correct. It is receiving messages, and it's up for 15 minutes, and it's got 2 prefixes that have been advertised. Then there's this command, show IP BGP neighbors. I'm using the loopback address of R3, 192.168.2553, since that's what it's pairing with. And everything looks fine. BGP state is established, up for 16 minutes. The remote AS is 65,001. That's correct. External BGP is not configured for connected checks. So that means that disable connected check is configured. And also the neighbor is up to 2 hops away. And finally, the table. BGP has a routing table and neighbor table. Here I've got 4 routes. 172.16.10, that's the LAN 1, that's directly connected, so there's no next hop there. And 172.16.20, that is advertised from R3. You can see the R3 loopback address there, 192.168.2553. 192.168.10, that's the local WAN segment, that's local. And 192.168.20/30, that's also being advertised from R3. That's the 192.168.20. There's the 172.16.20. So everything looks fine there. Let's do the same thing over here. And 192.168.2551. So it's pairing on the loopback to R1. That's good. 65,000 is correct. And 2 prefixes. And 18 minutes uptime. Here, BGP state is established. Amount of uptime. Remote AS 65,000 is correct. Also, BGP may be 2 hops away. And external BGP not configured for connected checks. And look at the routing table. So I've got 172.16.10. That's next hop is the loopback address since it's pairing with it. That'll be the next hop. So that's correct. There's 172.16.10 being advertised to R3. And 172.16.20 is a local, so that's all zeros. 192.168.10 is the WAN segment. That's advertised by the R1 peering IP address. There's 192.168.10. So I'm on R3, so it's getting that from R1, since it's on a different subnet. And 192.168.20 is local. And with the local route, you'll note they've got the default weight 32.768. And there's also the path statements in both 65,000. In an R1, it's 65,001. That's the path. 65,000 to 65,001 is next path. So I'll do a ping as well to verify there's connectivity from LAN 1 to LAN 2 and LAN 2 to LAN 1. Let's do a ping 172.16.2.2 and 100%. And also ping 172.16.1.2. There's 100%. This is 172.16.1.2. That's 172.16.2.2. And that concludes the lab.